Good day, students. Welcome to math.serve.com. In this clip, we're going to be going over how to find the local extrema of a given function. Don't forget to visit our website at math.serve.com for access to other cool math tutorials ranging from algebra all the way to calculus. All right, let's take a look at this problem. We're to find the x value of the local extrema of the given function. So let's say that the function that we're working with is f of x equals x to the 2/3 times the quantity 5 minus x. Okay? So when you're looking for the local extremas, we have to first of all find the potential extrema and then use the first derivative or second derivative tests to determine which is the extrema and what their values are. Okay? Now let's determine what the potential extremas are. So what are potential extremas? So potential extremas, just write this down. Potential extrema are your critical points and endpoints. Okay. So in this problem, we have an open interval. That means that endpoints are not applicable here. Okay, we're not going to take a look at the endpoints. We're just going to focus on critical points. So what are critical points? Let's go ahead and write down what they are. Critical points. These are points where critical points are where the derivative is equal to 0 or the derivative does not exist. Okay? So those are your critical points. It's a subset of your potential extremas. Alright, so this is what we're going to be doing. We're going to be finding where the derivative is equal to 0 and where it does not exist. Okay? Alright, so let's go ahead and find the derivative. F of x is equal to x to the 2/3 times 5 minus x. If you notice, we have a product of two functions here. Okay? So we're going to be using the product rule. So this is your u, and this right here is your v. So do you recall the product rule? uv prime is equal to vu prime plus uv prime. Okay? Alright, so let's apply this product rule to this situation here. F prime of x is going to be v, which is 5 minus x, times u prime. So let's just do the intermediate steps so that everyone understands what's going on. So vu prime plus u, x to the 2/3, v prime, 5 minus x prime. Okay, let's go ahead and find the derivatives and simplify. We're going to have the quantity 5 minus x. If we apply the power rule here, we're going to have 2/3 x and then subtract 1 from the power. That yields negative 1/3 plus x to the 2/3. The derivative of 5 is 0. The derivative of negative x is negative 1, so times negative 1. Alright, let's go ahead and simplify. We're going to have, let's see, 2 times the quantity 5 minus x divided by, now using the reciprocal property, this x to the negative 1/3 can become x to the positive 1/3. Okay, so we have 3 times x to the positive 1/3. All right, and then this minus multiplied by this plus becomes negative x to the 2/3. Okay, let's write this as a fraction so we can combine these two fractions. Let's see, we need to find the LCD. So in order to accomplish that, we will multiply this side right here by 3x to the 1/3 at the bottom and at the top. Okay, because the LCD of 1 and 3x to the 1/3 is 3x to the 1/3. Okay, all right, let's go ahead and simplify that. So we distribute this 2 to these two terms in this quantity. So that yields 10 minus 2x. And now if we multiply these two together, it's still going to be a negative. We add, using the product property of exponents, when you add x to the 2/3, you add the powers, 2/3 plus 1/3, you have 3 over 3, which is just 1. So we have x to the 1. All right? And we have that expression divided by the LCD, which is 3x to the 1/3. All right, let's simplify this. Let's write it down here. So f prime of x is going to be 10 minus 5x divided by 3x to the 1/3. All right, so now we have the derivative. So what we're going to do is we are going to, we need to find the critical points. Okay, the critical points are where the derivative is equal to 0 or it does not exist. So we're going to have to split this up into two parts. The first part is where the derivative is equal to 0. Okay, so let's solve f prime of x equals 0. So to accomplish that, we'll just set our result 10 minus 5x over 3x to the 1/3. We're just going to set that equal to 0. Okay? If we cross multiply this over 1, we're going to have 10 minus 5x equals 0. If we add 5x to both sides, 5x equals 10. Divide both sides by 2, divide both sides by 5, x equals 2. Okay? So there goes your first. Now, to find the second, to find the other critical points, we set the derivative, we find where it does not exist. Okay? So how do we solve this? This expression is undefined when the denominator is equal to 0. Okay, so we just extract the denominator, 3x to the 1/3, set it equal to 0. To solve this, you divide both sides by 3, x to the 1/3 equals 0. And then when you take the third power of both sides, you have x equals 0. Alright, so these are our critical points. Are they extremas? We do not know yet. Remember, your critical points are your potential extremas. Okay, critical points are x equals 0 and 2. Now, how do we know if they're extremas or not? We're going to be using the first derivative test. Okay, so let's set up our chart. Now we're going to graph the intervals that we have. Let me move my line downwards a little bit. Down. Okay, so the intervals we have, our critical points are 0 and then 2. So we do not have endpoints, so we don't have to consider graph any endpoints on our interval. Okay, so this is interval number 1, interval 2, and interval 3. Now, with this interval, what we're going to be doing is we're going to be drawing a connection. All right, first thing we're going to find is the sign of f prime. Okay, So we're going to connect that with the behavior of f. Okay, so we need it to determine the behavior of f. All right, so we need to pick test values to determine the sign of f prime on these intervals. So in interval 1, I'm going to select -1. Okay, that's an easy perfect cube that I can evaluate. Interval 2, I'll use 1. Interval 3, next perfect cube is 3. Our next cube. All right, now all I'm just going to be doing is finding the sign, okay? Remember, we do not care about the value of the number. All we care about is the sign. So for interval 1, I'll have to find f prime of -1. So to do that, we're going to plug in -1 into the derivative. Okay, remember what the derivative function is. Let's rewrite it. The derivative function f prime of x is 10 minus 5x over 3x to the 1/3. All right? So we have 10 minus 5 times -1 over 3 times -1 to the 1/3. Remember, all we care about is the sign, okay? So in the numerator, we have the difference of two negative, actually this is -1, and then if you times this right here, it's going to become a positive. All right, so we have, this is a positive over a negative, because in the denominator, it's going to be a negative. -1 to the 1/3 is -1, times 3 is also negative. Positive over negative is negative. For interval 2, f prime of 1, that's our test value. 10 minus 5 times 1 divided by 3 times 1 to the 1/3. The numerator is going to be positive, likewise the denominator. Positive over positive is positive, okay? So we have a minus here, positive here, and then for interval 3, f prime of 8, we're going to have 10 minus 5 times 8 over 3 times 8 to the 1/3. Now, let's see. The numerator, we have 10 minus 40, which is a negative result, and the denominator is positive, so we are going to have a positive first derivative sign in interval 3, okay? Actually negative, so we have a negative there. All right, so what do these tell us about the behavior of f on these intervals? How does f behave? Since f prime is negative on this interval, f is going to be increasing. F prime is positive, actually switch that around. F prime is negative on this interval, so f is going to be decreasing. And then since f prime is positive on this interval, f is going to be increasing. F prime is negative on this interval, f is going to be decreasing. Okay, sorry about that. All right, so now with this sign and this behavior, we can now determine where our extremas are at. So imagine a function decreasing and starts to increase. This makes this a local minimum, because you have like a U-type behavior here. Decreasing and then increasing, you have a minimum. Over here, imagine a function that was increasing and then starts to decrease. That makes this a local max. Okay, you were increasing before and then you start to decrease. So that's that. All right, so we just have to find a local extrema. So let's go ahead and write down the explanation of our results. So since f prime changes changes from negative to positive at x equals 0. F changes from decreasing to increasing. So we have a local what? A local minimum. Okay, we have a local minimum at x equals 0. All right, and then since f prime of x changes from um, positive to negative at x equals 2, f changes from what? F changes from increasing to decreasing. So we have what? We have a local maximum at x equals 2. Okay, so there goes our local extrema in this function on the open interval. Thanks so much for taking the time to watch this presentation. We really appreciate it. Feel free to subscribe to our channel for updates to other cool tutorials such as this. If you have any questions or comments, feel free to include it in the comments section below this video. More clips can be found on mathcodeserve.com. Thanks again for watching and have a wonderful day.